Very good morning. Welcome to KBS Engineering Mechanics video channel. In this video session, I would like to explain about jigs and jig and fixture of milling machine. So the main concept of machine tool is workpiece and cutting tool. And the fixture is a mechanical component which holds the workpiece and guides the workpiece towards cutting tool so that cutting tool can remove material. And jig is a mechanical device which holds the cutting tool and guides the cutting tool to remove the material of the workpiece. So mainly the cutter will be this will be a cutter. Cutter will be in the form of a gear with a cutting tool. So this will be cutter. This will be a cutter. And so on it will be. Now, this cutter is rotating. So a motor is required. A motor and a transmission system. A motor and a transmission system is required to remove the material from the workpiece with the help of this cutter. Now, what is the called jig? A jig is a device which holds the workpiece. That means there should be some mechanism or a bearing, we say, which holds this particular gear. So this is a gear, cutting gear, which is having a shaft, and this is held by a journal bearing. So this journal bearing will be a jig for the milling machine. Now the workpiece will be a rectangular plate, and a rectangular plate or a rectangular plane face, giant plane face, and this need to be moved towards this cutting tool, and it will. So you can make a slot. You can make a slot in this rectangular, or you can remove material. Complete plain material like a radius thickness. So this is say 50 cm. So I'm going to make it to 40 mm thickness, 48 mm thickness, 50 mm to 48 mm. So this particular thing. Now you got the jig is holding the cutting tool. Now the cutting tool. Flexibility is there. That means how many degrees of freedom we have to provide for this jig. Now, if it is fixed, there is only 1 degree of freedom. That means the degree of freedom will be only rotation. The degrees of freedom is only rotation. The other degrees of freedom, that means we can move this cutter to right or left. That means we can give 2 translatory degrees of freedom, and we can move up and downwards. 2 translatory degrees of freedom. So total how many degrees of freedom is having? Any object in hand 6 degrees of freedom. That means you can say it not say 2, 1. That means there is a motion, a rectangular rectilinear motion along z direction, or rectilinear motion along x direction, and a rotation of, that means from one rotary degrees of freedom is by default the jig should provide, and this complete mechanism of jig, the jig can be moved in 2 translatory directions. So at maximum one rotary motion is enough. If it is one rotary motion is provided by the jig, this fixture should have leftward x direction, y direction, z direction. Okay. If you are providing 2 translatory degrees of freedom to jig, so there is only 1 degrees of freedom you can provide by the jig, by the fixture. That means the plate can move up and down. The plate should move up and down. If you are not providing 2 translatory motions, translatory degrees of freedom to the jig, that means it should have 3 translatory motions. So in a milling machine, you can provide 1 rotatory degrees of freedom by default. 1 rotary degrees of freedom should be there, and you can provide 2 translatory degrees of freedom. Similarly, a fixture, this is for jig, a fixture will be having 1 degrees of freedom in z direction. That means it has to move up or down, upward and down. So we have to maintain depth of cut. 1 degree of up and down, and if you are not providing 2 translatory degrees of freedoms, you have to provide 2 translatory degrees of freedom in x and y direction. Okay, so this is all about the jig and fixture in the milling machine. So now we can see how the shape of milling machine okay, this will be a body. Now on this body, there is a provision to hold a jig, which will be holding gear cutter. Now it will be holding a gear cutter. Now on this a workpiece holder will be there, which is provided by arrested by jig. So fixture, and there will be a fixture which is moving x and y direction, x, y direction. So here, this is workpiece. Okay, this workpiece will be held by 2 end places, and this fixture is moving 3 translatory motions, and there is a motor. Here you have a motor, a jig which holds the gear piece, and a fixture which is holding the workpiece, and this fixture will be having XYZ motions, and this gear cutter will be having only Z direction. So that is what you have designed. That is, to design a milling machine, all these things should be there. So we'll see in other video sessions how exactly this particular diagram of this milling machine will look like. Okay. So in this video session, I have said that the cutting tool will be held by a jig in a journal, which is providing a degrees of freedom in z direction. Now you can, to design a milling, you can think about the motion of this particular jig in z direction and x direction. So these are the three possible degrees of freedom. So one rotated by default, and also a fixture joining the workpiece. You can, if you are going to do translating motion to the jig, you can provide only one translating motion on z direction, which is going upside and downside. Or if you are not providing two translatory motions on the jig, you can provide three translatory motions to the workpiece fixture. So this is what I would like to discuss in this video session. Thank you for watching the video.